So let's start with this blue box, the easy example. But think about where is the center of gravity of this box. So to get an answer for that question, we need to consider the box as infinite numbers of masses in the box. So there are a lot of masses, m, 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 m. And the center of gravity is a point of mass that can describe all the masses in a box. And if the box is symmetrical and distributed evenly, then the center of mass would be probably in the middle of that. So what is center of gravity? It's a point of mass that represents the physics of the whole object. So you don't need to calculate like the behavior of each small mass. You just use one point to describe the whole motion, the motion of the whole object. And you obey most of the physics rules like F equals to ma, kind of that. So it's also applied in human movement science. So in order to maintain balance, you need to keep your center of gravity within your foot or within your base of support. So in this case, the center of gravity is pretty close to the base of support. And if he lean a little bit more, his center of gravity will be outside of the base of support. And this gravity will generate a torque to rotate this guy counterclockwise, and he's going to fall. So the main concept of maintain balance is to keep your center of gravity within your base of support. So we're using center of gravity to describe complex human movement, and that's a pretty useful tool. So the first question is that can you change your center of gravity? Again, start from the box example. So if the mass are distributed evenly, then the center of mass will be in the middle. But think about if we move like this row of masses upward a little bit, it'll become like this. The mass are distributed on the upper part of the box. And we can see that the center of gravity will be also moved upward a little bit. So how do we move some of the mass in our body upward? This is an easy example. We move our arms upward. So assume like each arm is a small m in a box. We move the arm upward, so the whole center of gravity will move upward as well. So actually we can change our center of gravity by changing our posture. And the second question is, can your center of gravity be outside of the body? Sounds pretty scary, but thinking about from the box example, if it's the same box, but we dig a hole in the middle of the box, where would the center of gravity of this box be? It'll still be in the middle, but there became a hole, so the center of gravity is actually outside of the box. So how is that important in human movement science? Thinking about this example, in this kind of posture, your center of gravity is actually outside of your body. And to do a high jump, with this scale, you don't need to really move your center of gravity across the bar. Actually, the path of the center of gravity never pass the bar, as long as you can maintain a good scale, a good posture during the high jump. So that's a scale. You can maintain your center of gravity outside of your body and keep it below the bar. So you don't need to generate that much of potential energy. Okay, so that's about the basic concepts of center of gravity. And in the next video, we'll talk about how we can calculate the height of our center of gravity with this kind of lab setting.